Hello everyone, in this video we're going to look at how we can solve some exponential equations. So exponential equations are just equations in which variable expressions occur as exponents. And so we can kind of follow along with what's in pink here to solve these. If b is a positive real number other than 1, then b to the x power is equal to b to the y power if and only if x is equal to y. So essentially all we have to do is if the bases are the same on our two expressions that we're setting equal to each other, then all we have to do is take their exponents and set them equal to one another. Now this presents us with a little bit of a dilemma because what if the bases aren't the same? Well, then we have two options. We can make the bases the same if we can rewrite one of the bases as a base to a power, and then we can use some exponent rules there. If we can't, or if it's not easy to rewrite the bases to be the same, then we can use logarithms to evaluate our exponential equations. So let's jump into our examples here. We're going to start off with 81 to the x power equals 1/9 to the x plus 3. So obviously our bases are not the same. We have an 81 and we have a 1/9, but we can make the bases both be 9, right? We could do this. We could say 81 is 9 squared, raise that to the x power. 1/9 would be 9 to the negative first power, and we write that as same exponent to the x plus 3. So now we can use our, I call it, it's power of a power product. I call it PPP, power product, because it tells me what to do with those two powers. I take the product of them. So this is going to be 9 to the 2x power equals 9 to the negative x minus 3. Notice that we distributed that negative, so it is negative x minus 3. So now we can take our exponents, 2x and negative x minus 3, and we just set them equal to each other and we solve for x. So if I add this x over here, we get 3x equals negative 3, divide by 3, and we get our answer of x equals negative 1 for number 1. Okay. Now, if you notice on the other three examples that we're going to do, we don't have bases that are easy to rewrite to be the same. So we're going to use log here. So for number 2, we have 3 to the x power equals 8. So in order to get the 3 to the x power, that 3 to go away, we can take log base 3, because that's going to cancel out log base 3 of 3. That would just be x, right? So we're going to cancel out, or basically apply log base 3 to both sides. So we can say log base 3 of 3 to the x, and whatever we do to one side, we have to do to the other. So log base 3 of 8. So now log base 3 of 3, that's just going to give me x, and I know x is equal to log base 3 of 8. And so I can plug that in my calculator to get an approximation. Remember, to find the approximation of log base 3 of 8, we need to use our change of base formula. So I did a previous video on that. I'll link that in the cards right now. But essentially, essentially what we're going to do is we're going to take log of 8 and divide it by log of 3. So in my calculator, I'm going to do log of 8 divided by log of 3. And that's going to give me my approximation, which would be approximately 1.893. Okay. All right, number 3, 7 to the 9x power equals 15. So once again, base of 7, base of 15, can't easily write them as the same. So we're going to take log base 7 of both sides this time. So I'm going to take log base 7 of 7 to the 9x power equals log base 7 of 15. So the log base 7 of 7 is going to cancel out. So I'm left with 9x equals, once again, change of base. We could do log of 15 divided by log of 7. And if you check out that change of base formula video, you'll notice that we could also do natural log there. So we could do ln of 15 divided by ln of 7, and that's going to give us the same thing. So I'll do that one, ln of 15 divided by ln of 7. And that gives me 1.39, so I'll go ahead and write that down, but I'm not going to round it in my calculator just yet because I do want to divide that by 9 to get my final answer. So 1.392, and now we're going to divide this by 9, so I'm just going to type divide by 9 in my calculator, and this is going to give me x is approximately 0.155. Okay. All right, and our last one, number 4 here, we have 4 times e to the negative 0.3x, and then minus 7 equals 13. So I'm going to clean this up a little bit. Let's do some inverse operations. So we're going to add, so 4 times e to the negative 0.3x equals 20 now. And then let's divide both sides by 4. So now we have e to the negative 0.3x equals 5. And now if we have a base of e, we can apply the natural log to both sides, and that'll cancel that e out. So we can take ln of e to the negative 0.3x equals ln of 5. So ln of e, that'll cancel out for me there. So now I just have negative 0.3x equals, in my calculator I can do ln of 5, and that gives me 1.609. And now we're going to divide both sides by negative 0.3. So divide by negative 0.3. And that's going to give me x is approximately negative 5.365. Okay? And that is how you can solve some exponential equations.